AI and robots are going to need a massive amount of electricity. The problem is that electricity depends on a super unreliable component, insulators.
These protect the transmission tower from hundreds of thousands of volts and unfortunately break all the time, causing 70% of power outages. To inspect them, right now workers use binoculars, which is incredibly slow, or walk up towers, which is super dangerous. So to fix that, the National Research Council of Canada asked us to build a solution that would let them inspect these autonomously.
Alongside the NRC, we have developed a drone system that can autonomously fly along power lines and detect damage in the insulators and report it back to utility workers where they can go and fix them, while simultaneously avoiding collisions with aerial objects or the power lines themselves. We have taken an innovative approach to training our AI model. We have developed a photorealistic simulation environment where we can fly the drone and iterate through the AI models and the collision avoidance algorithms without the risk or cost of real-world deployment where we can damage power infrastructure.
So the whole process is pretty simple. All you have to do is place some waypoints beside the power line where you want the drone to fly. Once these waypoints are placed, the drone will start its mission. Once it starts executing the mission, it will fly along the same path and then start its detection model. When it flies beside the power line, you can see it will detect damaged and undamaged insulators both. As soon as it detects a damaged insulator, it will tag its location using its coordinates, and then at the end of the mission you can see the pointers to the actual tagged location.
It's good. I like the rendering. I like the setup. I think it's a good base, as you said, adding more type of different categories into it. I'm glad that you have already thought about basically tagging the telemetry and the location to the defects, because that's something that when you look at it in 10 kilometers, 20 kilometers, flight sweep happens, it's hard to go back and landmark it. So I'm glad that you have already taken care of that.
I really like the fact that you kind of started from scratch. You didn't have 3D models, you didn't have anything pre-built given to you except the YOLO model, and you build everything from scratch, and it's really in a very short time. So I'm very happy with how the project ended up.
Over the course of this project, we delivered a fully integrated drone inspection system in simulation. We built a photorealistic power line environment, connected Isaac Sim with ROS2 and PX4, and developed a real-time detection pipeline using a custom-trained YOLO VLA model. Our system can autonomously navigate, stream live camera data, and detect insulator damage during flight. Along the way, we learned that system integration is the hardest part. Simulation fidelity directly impacts AI performance, and real-time constraints shape every design decision. This project lays the foundation for fully autonomous inspection system in the real world.